We use switches every day to turn devices on and off. In this video, we're gonna look at 7 different ways single pole switches can be wired to control lights and receptacles in the wall behind me. Be sure to stick around for number 7, it's pretty fancy. We're gonna cover 3 and 4-way switches in a separate video. My name's Dustin, I'm a licensed master electrician. Welcome to this episode of Smarter Sparky. The first installation we're gonna look at is a single switch controlling a single light. I've already installed the 2 boxes and ran the home run. If you want more details on how that's done, go check out my installing multiple receptacles video. There I go into more details on drilling the holes, running the wire, stapling, and installing the boxes. We're really only gonna focus on the connection paths in this video. Additionally, I'm gonna be using 14 gauge wire for everything in this video because it's cheap and I have a roll of it handy. The concepts work for 12 gauge as well. This particular home run is fed from a 15 amp circuit breaker and goes directly to our switch box. Now we're gonna need a wire from our switch box up to our light. This is gonna be called a switch leg. I've got a used piece of wire here that came from another demonstration. On this particular style box, there are these little fingers that poke down, and we're just gonna run that wire through that opening, and then that little finger actually holds the wire in place. So this actually acts as a clamp for this box. Whereas on these cheaper boxes here, this back piece here actually just breaks out. These just break out on this box. There is no internal clamp. If you just break off one side of this knockout cover, it actually just breaks off both sides. They do make boxes that have that little finger, just like that light box did, but these cheaper boxes are not that type of box. And we'll run our wire in here. Remember, this wire going up to the light is called a switch leg, and the wire coming in on the bottom is called the home run. All right, so we're stapled. I got the wires trimmed, and I've got the sheath off within the boxes. Remember, this video, we're only really focusing on where the connections are made, how the wires are connected, and where they go. Not really gonna be focusing on installing the boxes, installing the wire, etc. I'm gonna leave the electrical panel cover on for the rest of the video. Everything we're gonna be modifying is gonna be out here to get different functionality for different switching scenarios that we wanna come up with. The only thing I'm gonna be doing in the electrical panel is turning the breaker on and off in order to work on this circuit. Remember to follow all electrical codes and safety procedures when working on electrical circuits. Let's start with the simple thing and wire the light up first. This is a keyless lamp holder. Keyless meaning it does not have a little switch on it. This is probably the cheapest keyless lamp holder I've ever seen. I am not a fan of these, but it's gonna be fine for our demonstration here. They all work the same way. If we take a look on the back side here, you're gonna notice these screws are gold and these screws are silver. Our black wire is gonna go to the gold screws and the white wire is gonna go to the silver screws. So where do we install the ground wire, right? A keyless lamp holder does not get a ground wire. So the ground we can actually just tuck in the back of the box. You have to be very careful when you tuck these in the back of the box because if that wire pokes out and touches either of these screws on the back of the fixture, it's gonna either cause a ground fault or a short circuit. So we want to avoid that, make sure that ground wire is tucked all the way in the back. I do not suggest cutting that ground wire off because you might need that ground wire in the future to extend a circuit, as we're actually going to see in the next demonstration. So we can land the white wire on either of these 2 screws. It actually does not matter which screw we land it on, and same for the black wire. We're going to land it on the gold screw. Does not matter what screw it lands on. If you really wanted to, you could screw down these extra screws here. I'm not gonna bother. And for right now, I'm actually gonna leave this box open. So once we get the switch installed, we're gonna be able to actually see how everything is connected visually. So down here in the switch box, we've actually got 6 wires and we have to figure out where all of these go. And if we take a look at the switch, we're gonna see there are 2 connections on the side. Notice that these are gold colored. That's gonna tell us that that's gonna have to do with the hot wire or the black wires. And there is also a green ground screw down here in the bottom corner. Notice there is no silver colored screw on this switch. That's right, the switch has absolutely nothing to do with the neutral wires. So the neutral wires we're simply gonna strip out and put a wire nut on them, and they're just gonna go straight through the box. Basically come right from the home run and go right up to the light. The switch, in this case, has nothing to do with the neutral. Single pole switches switches like this never have anything to do with the neutral. The only time the neutral is involved in switching is in fancy smart switches or electronic switches. So let's deal with the ground wires first. We need the ground that comes in from the panel to also go up to the light. Now, yeah, we're not actually using that ground wire up in the light, but it still needs to be connected. Because what if someday somebody does connect another circuit up there or another switch leg up there? Well, we're gonna need that ground to be available, so we have to pass it through. But we also need a ground for our switch here. So what we need to do is we actually need to pigtail a third little short piece of wire here to this switch. Now this is just a scrap piece of wire that I had laying around. We're actually gonna splice it into our ground wires. Do you need to pre-twist? No, pre-twisting is a personal preference. It does make it easier to make a good connection, but pre-twisting is not necessary to make a good connection. You can check if a connection is good by tugging on each wire, and make sure you're actually tugging fairly hard. If that wire moves, it's a bad connection. In this case, each wire passes the tug test. This is a good connection, even though we did not pre-twist. So that takes care of the ground wire. Now let's take care of the neutral. Again, the neutral is just gonna pass straight through. So stripping the neutrals out, and we can simply wire nut these together. Again, you can pre-twist if you want. It does make it easier to make a good connection, but pre-twisting does not automatically mean you're gonna get a good connection. Do the tug test. That passes, the neutral is done. So we can tuck the neutral up inside the back of the box. Remember, wire nuts are hats, not buckets. So the wire nut should be facing up and the opening should be down. Being a bucket, it would be upside down. You don't want debris to be able to fall into that wire nut. So all your wire nuts should be hats inside of the box. And we can just shove that all the way in the back, because it is not really needed at this connection point. We have to pass it through, but we're not actually gonna use it here. And same with the ground wire. We are kind of done with this connection here, but we still need the end of this pigtail wire. So same thing, we can tuck that ground wire into the back of the box. Remember, those wire nuts are hats, not buckets. So keep them facing up. Get that shoved into the back there. And notice we've still got this pigtail sticking out of the box. Now check this out. Now we've got 3 wires poking out of this box, and we have 3 connections on our switch. Both of these black wires are going to go onto the switch. The ground wire is going to go on the ground screw right here. So if we take a look at this little demonstration board here, this is literally the circuit that we're building right now. This would be our electrical panel. This black wire would actually be the white neutral wire. And then this red wire here is our switch leg, and this red wire right here is actually the black wire coming from the panel. So it comes out of the panel and it hits the switch. And all this switch does is what this knife switch does. All it's doing is connecting and disconnecting those connections there. And that's exactly what this switch does. When the switch is in the off position, these 2 terminals are not connected to each other. When we turn it to the on position, these 2 are connected together. So when we turn this switch on right here, it's actually going to connect these 2 black wires together and send power up to that light and, well, turn the light on. When we turn the switch off, it breaks that connection. See, that connection is physically broken there. So that switch can't be, or that light can't be on anymore. That connection is broken. So that is quite literally what we're doing right here. We are connecting these wires and disconnecting these wires. So our home run is always on, and the switch leg is the one that's actually being turned on and off. The ground wire is just an extra thing there for safety, and that's going to be tied on right here. We don't actually depict that in this simple little demonstration here. So all we need to do now is just land these wires on this switch. Does it matter which terminal these black wires go on, right? So if we put our switch like this, it should say off in the upper spot here, and when we flip it on, it should say on. If you flip your switch upside down, it tells you no, right? Let's see if we can get you in there. So if you flip your switch upside down and it says no, and then it's off upside down, that means your switch is installed upside down. So when you install your switch, make sure it says on and off, and it doesn't tell you no. If it tells you no, it's telling you you installed it wrong. So with that in mind, does it matter which one of these is permanent power and which one of these is your switched power? No. On a single pole switch like this, it does not matter which one's your hot and which one's your switch leg. So we strip these wires out, give them a slight twist. And remember, when we put these loops on our wires, we want to make sure the loops are going around the screw clockwise, not counterclockwise. If you put your loops under these screws the wrong way, the loop will naturally want to unwind as you tighten it. If that happens, you're going to get a loose connection and something's going to burn up. So make sure you loop clockwise. Also, additionally, make sure there is absolutely no insulation from the wire under that screw. If there is, you've got a bad connection and you need to redo it. And then finally, our ground wire, that also needs to be looped clockwise, because anytime you tighten a screw, it needs to follow the direction of the wire. And there we go. Now again, we want to make sure we put our switch in the correct position so it's not telling us no. And then we can fold our wires into the box. So with that, we are actually done in this box. Let's go ahead and put this together. And we'll put a switch plate on. And again, just to reiterate, that neutral came straight through. All we did was tie it straight through that switch box, but this black wire here comes from the other side of that switch. So when that switch is closed, power is allowed to come up here and turn the light on. And when that switch is opened, this wire will be dead and there won't be any power up here for the light to turn on. So we are actually done up here now. Remember, we got to be very careful of that ground wire back there. We don't want it to come into contact with either of those two screws. Again, yes, you could absolutely screw in those extra screws here just so they're flush, but let's be realistic. If a 1/4 inch is really making or breaking you on an installation like this, your box is probably too sloppy anyway. So I'm not gonna worry about it. This is just a demonstration. I have to put a limit on how far down rabbit holes we're gonna go in these videos. So let's install this lamp base. Again, I don't know how I feel about these all plastic lamp bases. Sure, they'd be fine for LEDs, but I don't know if I'd want to put a high wattage bulb in there. Look at that, there's not even a shell in there. It's just a little piece of copper poking out the side now. And I know I just said these would be good for LEDs, but hey, I got some old school incandescents here. They're only 40 watts, so hey, let's use those. I'm sure these will actually look pretty nice on camera. And with everything buttoned up, we can go ahead and test this. So we turn our power on. Turn the main on to 2, and we flip the switch, and behold, there is light. So just like this little demonstration right here, when the power is on, the switch is closed, and we've got a complete circuit here. You can see our light is on. Just like we've got here, the switch is on, which completes that circuit. Now we could think of it as power coming out on the hot, going through our home run, up into the switch, and it's passing through that switch up to the light. It's going through the light and coming back on the neutral. And remember, the neutral in this box down here just feeds straight through and goes right back to the panel. There is our complete circuit. Now, that is the way we can think of it. Remember, this is AC, so it's going out on the hot wire just as much as it's coming back on the hot wire. It's oscillating back and forth. So technically, it's also coming out on the neutral, up to the light, through the switch, and back to the panel. It's oscillating back and forth. If you're new to AC systems, don't worry about it. Just think of it as power coming out on the hot and going back on the neutral. It works to understand it that way as a beginner. So what if we wanted to control multiple lights from this installation? What if this was a hallway and we needed to control multiple lights? For this demonstration, let's just add one more light right here, and we'll control it from this same switch. Before we do any additional work, let's shut that circuit off. So I added a second box. Let's get another wire between these two boxes. All the work we're gonna do is actually gonna be in this light box right here. We actually don't need to do anything in this switch box for this particular scenario. So we open that box up. I've already drilled another hole right here off camera, and I'm just reusing a piece of wire that I used in another demonstration. Again, we'll poke this wire up through those little fingers in the box. Those little fingers act as a clamp. We only need about 1/4 inch of sheath inside the box. And I'm just gonna poke this one up using the same hole that the other one came through. In these particular boxes, it'd probably be okay to come in to that knockout closest to the stud. Remember, there is an 1.25 inch rule from the face of the stud to the edge of any of our wire. So I wish I could tell you there's just a general rule that you have to follow. Unfortunately, it's a little more complicated than that. So it's gonna be a case-by-case basis on which knockout you're able to use. If you're gonna be close to the front of that stud within 1.25 inches, you can't use a particular knockout. And that's actually the frustrating thing about electrical work is there are so many little nuanced rules. It's not just a general, hey, you can do this every time. It's, well, you can do this in certain situations, you can't do it in other situations. So let's get everything strapped here. And again, we're focused on the actual connections here, not the particulars on how things are being routed. This is a small demonstration wall. You know, these distances could be 20 feet, 30 feet, 100 feet. We're looking at the bigger picture here on how things are connected. In this scenario, we don't have to do any work in the switch box. So the switch box is actually done. All the work we need to do is gonna be up here in these two boxes. Let's start with the original box and we will finish with the new box. These two wires right here come from our switch box, and this new set of wires right here goes to our new light over here. Now, these lamp bases do have these extra terminals right here, and we could simply just tie our neutral over here on this terminal, and we could put this hot wire, it's technically a switch leg now, over here on this gold screw and pass through this way. I don't recommend that. I don't like using fixtures as pass-throughs for circuits, so I am actually going to pigtail everything here. Yes, it is a few extra seconds of work. I have found in the past, though, that it does make a difference in longevity of our circuits. So ultimately what we need to do here is we're gonna remove these two wires off our original lamp. We're gonna pigtail the neutrals, we're gonna pigtail the switch legs, and we're gonna have a third wire coming out of each of those connections. Those third wires are gonna replace the wires going to this light, and then the continuation will come over here, and then these wires right here will land directly on this new light over here. Because we don't need the ground is gonna get tucked in the back, but remember, we need that continuity of ground. Because we have a ground wire over here, it has to be connected. So all we have to do for our grounds are connect these two together and then shove them back into the back of the box. But it is the hots or the switch leg and the neutrals that are actually gonna get pigtailed because that's all we need here on the lamp base. So first I'm gonna get these grounds out of my way just so there's a little bit of extra space to work here. Those are twisted together. Again, pre-twisting is totally a personal preference. Pre-twisting does make it simpler to get a good connection right away though. Now we will undo our original connections here. The only time you should be working on an electrical circuit is if you are qualified to do so and the power is off. So we'll strip these new wires out and straighten out the existing ones. Remember, we had to put these loops on for the last scenario. All right, so I know this looks like a mess of wires here. What do we have going on? Again, this set of wires comes from the switch, and this set of wires goes to the next light. So these two neutrals are gonna get tied together and these two black wires are gonna get tied together, but we still need to feed the light that was here. So we need an extra wire coming off the neutrals and an extra wire coming off the switched hots. So let's add a pigtail to the neutrals. Make sure the tips of the wires are all the same length. And twist our wire nut on. remember, do a tug test. That's gonna tell you if you have a good connection or not. And we add a pigtail to the switched hots. Make sure the tips of the wires are all lined up. Give them a tug test as well. All right, now we are done with these connections, so we can shove them into the back of the box as well. All we need are these 2 wires poking out. So we will fold those around. Remember, wire nuts are hats, not buckets. Don't leave them upside down where debris can get in there. Sideways is okay, but we don't want debris to be able to get trapped within the wire nut connection. So there are our 2 connections poking out right there. Now those 2 connections can simply get landed on the back of our fixture. Tighten down the neutral and tighten down the switched hot, or switch leg. We're done in this box, so let's button it up. And now this second box becomes just like that first box that we did originally. We're just gonna tuck that ground wire in the back, white to the silver screws, and black to the gold screw. We're done in this box. We can button it up now as well. Install our bulbs, turn power back on, and test our lights. And we can see both lights work now. Again, all this switch is doing is interrupting power, and now we're turning on and off whatever is fed from this switch. So we could keep daisy chaining this down a hallway. It could be in an office building feeding a bunch of fluorescent lights, LED lights, or any other type of light that we might be installing. All we would do is keep pigtailing in the boxes as we go down the line, and the very last light will simply just get landed right on the light fixture itself. What if we wanted to control these lights separately? Let's remove the wire between these 2 fixtures and add another switch. And of course, before we do that, we gotta shut power off. All right, so I removed the wire between the 2 lights, added another switch box, and I disassembled our original switch box. So now we have our original home run coming into our box here, and we have this switch leg going up to our original light. We're gonna add another switch over here to control this light. Now, I left this original wire in. We can swoop this down into our box over here as the switch leg for this light, so we'll reuse this wire here. But we're gonna need a way to get permanent power from the home run over here to this box. So we actually need to add another cable from this box to this box. Again, I'm just gonna use a piece of wire that I already have from the previous videos I've made. So I'm gonna install this between these 2 boxes right here. This new wire, I'm just gonna use the same knockout that our home run goes through. This box right here would definitely be a case where we cannot use the knockout closest to the stud, because on the back side here, we would be less than 1.25 inches from the face of this stud. Now that, again, there's lots of nuanced rules with that as well. I can't say that that's for every installation. If we were to take this installation in the literal sense that there is a concrete wall behind here, then yeah, we could use that knockout, because there is no way drywall could be installed on the back, and there's no way a drywall screw could be ran in sideways and poke that wire entering right here on the back side. That's the whole reason for that 1.25 inch rule, is to make sure that when drywall is installed, if a screw goes in sideways, it's not gonna poke our cables going into our boxes. And we'll bring this switch leg down into this box as well real quick. So here's where we stand. Our home run comes from the panel into this box right here, and that is this set of wires right here. So there's 3 wires in this box so far. We've got 9 in here now. This other set of 3 wires actually comes back out of the box, and it's gonna feed permanent power over to this switch box. So ultimately, these wires right here are all gonna get tied together through pigtails. These 3 wires in the top of our original box go up to our light. So these are the switch leg for the left light. And then these 3 wires over on our new box go up to the other light, the right light, and that's going to be the switch leg for that one. So when we think about the flow of power, again, we're going to have permanent power coming in this way, permanent power going this way. So we know that this is all permanent power and has to be tied together accordingly. These are just going to be our switch legs. So all of the neutrals are going to feed straight through, as well as all of the grounds. The really only complicated thing we have to think of here is what happens to the black wires. Which ones are always on and which ones are going to be switched. Let's start with the simpler box over here, because we've already done a box like this. We've got permanent power coming in and we've got switch leg going out. And just like before, our neutrals are going to go straight through. Remember, wire nuts are hats, not buckets. The grounds are going to get pigtailed, because remember, we've got ground coming in. We have to send ground up to the light even though we're not using it because it's there. And we need a ground here at the switch. So we have to pigtail this ground. And then we can tuck the ground into the back of the box. Again, making sure the wire nut is a hat, not a bucket. And that leaves us with 3 wires poking out. We've got our ground, we've got our permanent power, and we've got our switch leg. And we can land those wires accordingly. Again, on a single pole switch, it doesn't matter which one is switched power and which one is permanent power. You can flip-flop them, it does not matter. The only thing that really does matter is that you loop your wires clockwise. So as the screw tightens, it twists with the screw, not out of the screw. And with that, this box is done. Make sure you orient the switch so it says off at the top and then on at the bottom. Make sure it's not a no switch. And since this box is simple and we're done with it, let's just go ahead and put our switch cover on now. And we can reinstall the lamp for the right light as well. Nothing fancy here, exactly like we did before. Color to color on the screws. White to the silver and black on the gold. In this case, these cheap lights, this screw is bent, so I'm gonna use this other gold screw instead. Not impressed with these cheaper lamp bases. And I suppose while we're at it, we can actually just button up this left light as well. It's gonna be the exact same thing as the right light. We've got a switch leg coming up into the light. We've got a switch leg coming up into the light. All it needs to do is land directly on the lamp base. Again, we don't need that ground wire. We just tuck it back there, make sure it cannot come into contact with these terminals. All right, now the tricky part. Let's tackle this box right here. When it comes to boxes that start to get full like this, and there's a lot of wires here, it gets overwhelming. The best way to think of these is ask yourself, what is getting installed in this box? And we know the answer to that question is one of these switches. So we need to say, self, how many wires do we need to connect in this box? And the answer to that would be 3. Right? We've got 2 black wires that are going to land on this switch, and we've got a ground wire. So we need to look at this from 2 directions. Yeah, we've got an overwhelming amount of wires here, but we also need to look at it from the other perspective. We need to boil this down to 3 wires. So how do we boil this down to 3 wires? First and foremost, I suggest starting with the ground wires. The ground wires, they're easy because you know you need 1 ground wire here at the switch, so we need 1 poking out. But then we just know automatically that all the grounds just get tied together. All of these ground wires, let's tie them together. We have to leave ourselves a pigtail here so we can tie onto that switch as well. Give everything a tug test. Make sure all of those wires are in that wire nut good. And now we are done with the ground wire. And it's gone. And now we are done with the ground wire, so we can tuck this into the back of the box. Again, remember, wire nuts are hats, not buckets. And there we go. There is our ground wire poking out. Now let's tackle the neutrals next. So again, on a seemingly more complicated box like this, we have to ask ourselves, do we need a neutral at this box? And as we've seen in previous installations that we've just done, we don't need a neutral on these switches, right? So all we need to do is tie all of our neutrals together and they're just gonna go straight through in this particular case. There's no need to pigtail here because we don't need the neutral here. And again, we can just think think of the neutral as the return path back to the panel. Yes, it's AC, it works both ways. We're not gonna get into that. We can just think of it that way. So we can think of the black wires as our supply, and we can think of the neutrals as our return. Yes, they do both technically. We can put our wire nut on our neutrals, give every one of them a tug test. None of these pulled out, and we can tuck those neutrals into the back of the box so they are out of our way. Now's the tricky part. We need 2 black wires, and we've got 3. Here's how we break this down. This is the wire that power is actually coming in on. This other wire leaving the bottom actually goes over to our other switch. So this also needs to be permanent power. So we're actually gonna tie these 2 together so we can pass through that permanent power to that other switch. But that would only leave us with 1 black wire here. So in order to have 2 black wires here, we have to pigtail this junction point right here so we have that extra black wire. Simply pigtail this together. And now we've got 2 black wires at this box for switch to land on, and we've got that 3rd wire, our ground wire. Now we've got our 3 wires, now we know the box is complete. Just to reiterate, our power comes in from the electrical panel on this cable right here. The hot comes up into this wire nut, and it goes right back out on the other wire going to our other switch. So we have tied incoming power and outgoing power out to that other switch, and we tapped off of that so we can get permanent power for this switch. This black wire goes straight up to our light. So this is going to be the one basically where we're connecting it and disconnecting it, connecting it and disconnecting it. That's how our switch is going to work. Because this is all one circuit, our neutrals feed that light, and our neutrals go on and feed that next switch, which in turn feeds the other light. So we can tuck this wire nut in to the box, and that leaves us with 2 wires poking out, 2 blacks for the switch. Now we land all these wires. And just like that, this connection is done as well. Button this up. And with everything buttoned up, we can turn our circuit back on. And we can see that this switch now controls this light, and this switch controls this light. And they are now independently controlled because, again, both lights have permanent power because we're taking permanent power from our home run, and we spliced it right onto this wire feeding this light. So this wire right here is a continuation of that permanent power. So with permanent power at both lights, we are simply opening and closing that circuit going up to the lights themselves, thus independently controlling them, even though we've got a common permanent power. Now, what if we wanted 2 switches at this location? One switch to control this light and another switch to control a receptacle. So for this next iteration, let's add a 2-gang box in place of this switch, put 2 switches in this box. One switch feeds the light, the other switch feeds the receptacle. And of course, before we do that, we need to shut the circuit off. So we're gonna swap this box out for a 2-gang box, and then we're gonna put another single gang box there. So there's gonna be 2 switches installed here. One switch is gonna control the light above, and the other switch is going to control the receptacle we install over there. Let's just pretend that receptacle is gonna be for a lamp in a living room. So that means we actually have no work in this box right here. This first switch box is gonna stay as is. We have power coming over on this cable right here, so we're gonna be able to do everything we need to do at this new box right here. Little off topic, but here's a good reason why you don't have to pre-twist. It twists automatically when you install it. See, this style box actually has those little fingers. So these, the one side does not come off. I didn't realize it when I bought these boxes, but see, these boxes, they don't have the finger. They just break out. There is no mechanism to keep that knockout in place. I prefer this style box with the little fingers in it. All right, so this has been swapped out for a 2-gang box. Literally all we did was pop the box off and poke the wires back in. These wires right here go up to that second light. These wires right here are the continuation of our home run, and this is what provides permanent power. This is our switch leg. Now, because we're gonna add a receptacle to that stud over there, we're gonna need a set of conductors to go over there and actually feed this. That set of conductors will be another switch leg to feed this receptacle. So we're gonna have one incoming power. We're gonna have 2 switches. One switch is gonna control this switch leg, and another switch is gonna control the switch leg going over to the receptacle. We'll nail this box up right here, and we'll run our switch leg over. So again, this is our first switch box over here. This down here is our home run coming in. Remember, in this box, we split off and brought permanent power over here. So this is our permanent power. I just added another set of conductors, another cable from this box right here, all the way down and around to this box over here. Now, ideally, I would have had these flip-flopped around, so these wires down here would have crisscrossed, or not crisscrossed rather. Semantics, it doesn't really matter. It makes it look nicer if they lay properly. Down here, they're slightly twisted a little. I know you can't see it in the camera right now, but it is nice to plan ahead for how wires are going to lay in. Again, that's a little hard to do when we're iterating through different setups here. We're gonna make it work though. So this is our switch leg going over here. So this wire comes over here. So this is our incoming power, and these 2 are gonna be our switches, which means that this black wire is going to feed this receptacle, and this black wire is going to feed that light that's right above. This would be our second light. Again, when things start getting complicated and we have a lot of wires in there, it's easiest to ask ourselves, what assets do we have? Well, we've got incoming power, and we've got 2 sets of switch legs. And then we have to ask ourselves the question from the other direction, what do we need there? Well, here we're gonna be installing 2 switches. So we need 2 sets of incoming power, and then we need to send a switch leg up to their respective locations, but we also need 2 grounds. So we're gonna have to figure out how to get 2 grounds here. But remember, all of the grounds that are already here coming through on our NMs, those need to be tied straight through also. So let's start with our grounds. Let's grab all of our grounds, kind of isolate them here together in the middle so we can work with them. And we need to tie all 3 of these together. Again, our incoming ground, our switch leg to the receptacle, and our switch leg up to the light. Even though in the light we're not using that ground, we still have to provide that there if it exists. So since we need 2 grounds at this box, we actually need to have 2 pigtails coming off of this as well. So there's already 3 ground wires here. We're gonna actually have to add 2 more ground wire pigtails so we can ground those switches. And for pigtails, it's best just to grab some scrap wire that you have if you've got little pieces that you've cut off. That way you're not wasting wire that could be used in a longer run. So we trim everything the same, all the same length. Now, here we've got quite a few wires. This is a situation in which I will pre-twist. When we've got that many wires, there is a very good chance that one of those wires is gonna end up getting screwed out of that connection. So all I did was just give them a very rough pre-twist, not even a full turn. That way they're starting to turn the right direction. Now I can go ahead and put my wire nut on, and the wire nut will take care of the rest of that. So we just need to make sure the wire nut is on good and tight. And as always, give everything a tug test once you get that wire nut on. If any one of those wires moves, you have to redo the entire connection. I just tugged on all 5 of those wires and nothing moved. And here is a good illustration. When we do that, it automatically twists itself. So with the grounds all twisted up, we've got 2 ground wires here available at this box now, and we've fed all of these ground wires through. Now we can push this ground wire into the back of the box. Remember, wire nuts are hats, not buckets, so let's make sure that wire nut is facing up. There are people out there that can lay these in there very pretty. I am not one of those people. All right, with our grounds out of the way, now we can deal with the neutrals. We have to ask ourselves, do we need a a neutral at this box. Well, at this box, we're only gonna have 2 switches. So those switches have nothing to do with the neutral, so we don't actually need to tap the neutral off here, but we do need to distribute that neutral to where it belongs, at the light and at the receptacle. So we need to splice everything together here, but there is not going to be a need for a pigtail. And we throw a wire nut on the neutral, and we can tuck the neutral right in the back of the box as well. Now we've got 3 black wires and 2 ground wires. The 2 ground wires, that's exactly what we're looking for. We actually need 4 black wires here. And the reason, of course, for that is we have 4 gold screws here. So 2 of these gold screws are gonna be our switch legs. One's gonna go up to the light, the other's gonna go over to that other receptacle. And then the other 2 are gonna be the power, the permanent power feeding these switches. So we've actually only got 1 permanent power right here. So these 2 black wires right here are our switch legs. This black wire goes over to our receptacle, and this black wire goes up to our light. So we've only got 1 permanent power, but we need 2 permanent powers. So how do we handle that? Pigtailing, of course. All we have to do is splice this single wire into 2 pigtails, and those 2 pigtails can land on the single pole receptacles, feeding them power, and then these other 2 black wires are our switch legs. So again, we line up the ends, throw our wire nut on, making sure that all of those wires are flush at the ends. Give each wire a tug test. Every single wire in the connection should get a tug test. And there we go. There are 4 wires. We've got 2 permanent power wires now, and we've got our 2 switch legs. So this permanent power we can tuck into the back of the box, at least the wire nut portion of it. Now we've got our 6 wires that are gonna land on our 2 switches. Let's start by landing the ground screws. Grounds are pretty easy. Those are pretty obvious where they belong. We'll get those both tightened down. Plus then that way our switch kind of hangs right here so we can more easily see what we have to work with. So now we need to make a choice of what switch is going to control what. I think it would be logical for the switch closest to the receptacle to actually control the receptacle, and then it would make sense to have the other switch control the light that is right above it. Remember, this light switch is still controlling the light that's above it, so this light switch will control the light that's above this 2-gang box. So we need to be careful that we divvy up these switch legs appropriately. Notice this switch leg is kind of on this side, and this switch leg is over here. Well, this switch leg right here is what goes up. So this switch leg actually needs to go on this switch over here. So we kind of need to swap these. When in doubt, it's just best to kind of trace things out and ask yourself, where does this wire go? What is its purpose? And remember, we can start working the problem from both directions. What do we have there and what do we need there? We know for sure we can land these permanent powers on these switches. It doesn't matter which one goes where, because remember, they're pigtailed together. They are very much the same signal, so we can tie them on. Remember, it doesn't matter which one is permanent power on a switch and which one is not. It does matter on 3- and 4-way switches, but for single pole switches, it does not matter. I'm gonna kind of pull things out of the box here again, just so you can see things a little more clearly. This is that incoming power line right here, and we pigtailed that off to both switches. So we can see basically we T-tapped it and fed both of these switches. Now our switch legs are gonna land on the other sets of screws. So I'm gonna tuck this pigtailed power back into the back of the box so it's out of our way. The reason we're tucking these wires into the back of the box and actually shoving them back there is because the switch is actually going to take up space in the front of the box. So we need these wires in the back, far enough back that there's actually room to install the switch in the front. So we decided that we wanted this switch to control that receptacle that we're going to install over here. So the wire that goes to the receptacle is this one. This is our switch leg. So that one is going to come over here and land on this switch, which means the wire going up to our light, this one, is going to land on the left switch. So since that one's already got a loop in it from the last example we did, I'll go ahead and land that one first. And now the switch leg going to our receptacle, we will be able to land on the other switch. And now with these 2 switches landed, we can actually fold them back into the box as well. This can definitely get a little tricky, especially in boxes that have multiple circuits going through them or have even more wires coming out of them going off to various points. One thing you'll really want to be careful of is those ground wires. Remember, those are bare ground wires coming from that NM or that Romex. You're gonna want to make sure that they don't rub along the side here where these gold colored terminals are. That is a really common point of short circuits out in the field. That's why we got to be very careful that we fold those ground wires into the back of the box as far back as we can. That's also why I like to do those ground wires first, because then they're in the back of all of that mess of wires within this box. Now, what are the chances I have a 2-gang switch plate? Very slim to none. Run out to the shop quick, see if I got one. So we mounted both switches in the box and put a plate on it. Yeah, I know these screws don't match. This is a used plate and I couldn't find any screws, so that's what I had. And the wires simply land directly on the receptacle. White wire to the silver screws and black wire to the gold colored screws. Ground to the green screw. Does not matter top or bottom which screw on the neutral goes to. Both of these neutrals are tied together through a little bridge right here. Same over on the gold colored screws for the hot wire or the switched hot. There's that little bridge between the two terminals that connects them together so they're the same connection point. And install a cover. All right, and if we turn power back on, you can see we left this switch on. So this switch still controls this first light. Now this switch controls the second light. And this switch is going to control our receptacle over here. So receptacle is off right now, but we flip the switch and we can see both lights on the tester come on. I'm gonna plug in another tester as well and we can see both receptacles, top and bottom, turn on and off at the same time. So we flip all of our light switches and we've got all of our devices energized. And a close-up of that receptacle. Pretty neat. So if this receptacle was in a living room, what if we wanted the top receptacle to be on all the time and the bottom receptacle to be switched? So same single gang box here, same duplex receptacle, but could we make it so this top one is on all the time and this bottom one is switched? Yeah, we can, let's do it. First and foremost, we gotta shut power off and we need to ask ourselves, what do we need to change here? We actually don't need to change anything at this first switch box, nor do we have to mess with any of the lights. The only changes we really have to make are from this box to the receptacle. Now, as we've been doing so far, we've been asking ourselves, what do we have and what do we need, right? So let's ask ourselves that question for this duplex receptacle box. What do we have there? Well, we've got neutral and we've got ground and we have a switched power. So we've got switched power. So we've got 3 wires there. Now, if we wanted one of these receptacles, the top or the bottom, to be permanently powered, what would we need for that? Well, we'd need a wire that's got permanent power going out there. So how do we do that? The easiest way is going to be to use 14-3 wire. This is all 14-2 wire. It's got 2 conductors plus a ground, so 14-2 actually has 3 conductors in it, because that makes sense. And 14-3 actually has 4 conductors in it, because that also makes sense, right? This is actually gonna have a ground, a neutral, a black, and a red wire in it. So we're actually gonna have another wire in this cable that we can use to carry that other signal over, that permanent power. So we're gonna replace this cable right here with a new cable that's got an extra conductor in it. So with power off, we're gonna open this box back up, and replace that wire between them. So with everything exploded here, we need to remove this cable right here. So we're gonna actually have to trace these out and pull them out of the wire nuts they're connected to. Now the trickiest one, of course, is gonna be this ground wire nut right here. So fortunately, it looks like this wrapped around on the outside. So we'll pop that one out. I am just gonna throw this wire nut back on temporarily. We're still gonna have to add another ground wire under this, but that way these wires right here don't unwrap and we lose that twist that's already in them. So the ground wire in the cable that we're removing has been removed. Looks like this neutral goes up here. That also needs to be removed. Again, same thing. I'm temporarily going to put this wire nut back on just to keep these two together while I'm working on everything else. And finally, this black wire going to the switch needs to be removed as well. All I'm doing is tracing out all the wires from this cable that need to be removed and removing them from their respective locations. Now we can separate this wire and pop it out. And I'm just using my screwdriver to hold that finger open so the wires can slide out. And then on this side, we pop this strap off and we can pull this wire out and we'll replace it with a 3 conductor, which remember actually has 4 wires in it, because that makes sense. Now, could you have ran another 2 conductor over here? Absolutely. That does get a little fuzzy though on how that should work, because then you would have 2 neutral wires. And there is an argument that says you cannot have parallel conductors in that case. So it becomes a little bit of a gray zone on doing that, but it is doable. I'm gonna leave this a little long so we can pigtail if we need to and poke this up into the box. Same thing, I'm not really worried about how these wires are folding together down here. Ideally, you would plan it out a little nicer so they all fold together nicely rather than crossing. And as you can see, the new cable that we pulled actually has 4 wires in it, even though they call it 14-3. It's 3 conductors plus a ground. So now we've got an additional red wire, and we're gonna be able to send permanent power on one of these and switched power on the other. So over here on the main box, let's get this set up first. First things first, I'm gonna get the ground dealt with so we can tuck that ground all the way in the back and get it out of the way. When these boxes start getting a little more full like this, we start to have to be a little more aggressive with how we push wires around. Notice I just kind of wrapped that wire naturally with the wrap that's already there. And then I'm gonna trim it flush with the front of the rest of the ground wires. Now it's already got that twist in it. Now we can twist our wire nut on. Again, anytime we touch a wire nut connection, we have to double check every single wire with a tug test. And if any one of them fail the tug test, the entire connection has to be redone. Tuck the grounds into the back of the box. Then the neutral, I'm gonna kind of route through with the rest of the neutrals. That way they all kind of follow the same direction in the box. Cut it the same length as the others. And just by hand, I'm gonna kind of pre-twist around there with the original twist that was there. Remember, that original twist came from the fact that we twisted the wire nut on it. I never pre-twisted this myself. And as always, give all of those wires a tug test. Tuck the neutrals into the back of the box. And now we've got 2 wires left that need a home. So we need to make a choice now. What color is gonna do what? Well, because permanent power comes in on the black wire here, I'm just gonna choose, let's use the black wire as permanent power over here. So we're gonna land this black wire on the splice we made with our permanent power pigtails, right? So this junction right here is actually feeding both of these switches with permanent power, and we need permanent power. So we're gonna land this black wire going over to the receptacle under the same permanent power wire nut. So we spin that off, still holding them together with my fingers here, and I'm gonna cut them the same length and get them stripped out and cap it with a wire nut. Always give it the tug test. That passes. Good. And now we can tuck this permanent power splice into the back of the box as well. We are done with it for now. All right, we've got 1 wire left, but we've also got 1 terminal left. This terminal right here is the switch leg for the receptacle over there, and the top of this already has permanent power. So this is our switch leg, and we're gonna use the red wire as our switched power to that receptacle. So this red wire gets landed on this available terminal on the switch that's going to feed the switched portion of that receptacle. Making sure to loop that wire on clockwise with the screw. And we can shove the switches back into the box. Put the switch plate back on, and naturally to keep things fresh, I'm gonna put those mismatched screws in all different locations this time. My gift to you. To be clear, I would not let this fly out in the field. Again, we are more worried about the actual connections here than the aesthetics of this plate. All right, so what about our receptacle here? So we want the top, I actually already forgot what I said earlier. I think we're gonna make the top permanent power and we're gonna make the bottom switched power. So maybe we could plug our TV into the top receptacle here so it is always on and always has power, but maybe this bottom receptacle is for a lamp that we can turn on from the doorway. So in order to make this switching possible, we're actually gonna have to take advantage of this little bridge connection right here on the hot side. Notice the neutral actually has one of those little bridges as well. And again, we can tell the neutral side has the silver colored screws, hot side has the gold colored screws. So the neutral side also has that little bridge back here. Now we're gonna keep the bridge on the neutral side. Because this is a shared circuit, both are gonna be fed from that same neutral, so we're gonna keep that jumper in. But because we wanna control these receptacles independently, we're actually gonna break that little bridge connection right there on this receptacle. And the way we do that is we simply grab it with a needle nose pliers. That's actually why it's at that angle that it's at. If I can get this all into focus here. We grab it with a needle nose and we just bend it back and forth a few times. I'm gonna do a little fast here. And there we go. See that little bridge broke off? Now those two terminals are completely separate. So now we can actually land our separate control wires here on those terminals and get two different ways of controlling these receptacles, permanent power and switched power. Again, we're gonna leave this bridge on the neutral side so we can just share this neutral right here. Otherwise, black and red are gonna control these two gold colored terminals separately. We're actually gonna use all four of these wires, so I'm gonna get these all prepped, stripped, and looped. Ground goes on the green screw. Neutral is gonna go on either of the silver colored screws because remember, we are still jumpered with this manufacturer supplied jumper. If for some reason you do have a split receptacle and you need them fed by the same neutral, but somebody did remove that bridge, you could just simply pigtail and put one pigtail up top and one pigtail on the bottom. That way you're still feeding both with the same neutral. And then over on the hot conductor side, now we're gonna land the two extra wires that we have, the red and the black wire. Now remember, we wired this black wire as permanent power in the box just off to the left of the screen, and we wired up this red wire as switched power. So I believe we said we wanted the top receptacle to be permanent power, so we're gonna land the permanent power switch leg on the top portion of the receptacle. And we're gonna take our switched power and land it on the bottom terminal so it feeds the bottom receptacle. These terminals correspond to the side of the receptacle they're on, top or bottom rather. And with everything landed on the receptacle, this can be buttoned up now. And a receptacle plate, of course. And with everything buttoned up, we can go ahead and fire up our circuit. Notice I've already installed the receptacle testers over there, and we can see this top plug is actually on, but notice this bottom plug is off. So if we flip this switch right here, our bottom receptacle comes on now. So this gives us that flexibility of being able to have permanent power at a location as well as switched power for lamps or whatever else you may need switched. And of course, our existing installation still works as well. This switch controls the first light, this left switch controls the right light, and of course, the switch here on the very right controls that bottom receptacle. How neat is that? This concept could go on to feed multiple different loads. Instead of splitting a receptacle, maybe we've got a chain of receptacles that we feed with 3 conductor. Now in this case, I've got 14-3, could be 12-3 as well if you're running all this in 12 gauge. Remember, all these concepts, they copy right over to 12 gauge as well. So rather than splitting our receptacles, maybe every other receptacle could be switched and then every opposite receptacle would be permanent power. Or maybe instead of us actually switching a receptacle, maybe we're switching another light that's at the end of the chain of receptacles. So perhaps all the receptacles in that chain are permanently powered, but we're going to use that extra wire going through those boxes as a switch leg for a light that might be on the other side of the house. The possibilities here are limitless. We are able to use this concept of understanding what do we have, what do we need, and how do we get it within each of these boxes. I'm going to tear this all down and I want to show you something a little more exotic. What if instead our home run actually goes into the light first? How do we switch this? Well, let's start by asking ourselves the same questions we've asked before. What do we have and what do we need? Well, up here in the light, we have a neutral and we know we need that neutral at the light. So we've already got the neutral at the light. We have a ground here, but we don't need it at the light itself, but it's here so we can propagate it if we need to. And we've got permanent power here. Well, we want switched power here. So somehow we need to figure out how to send this permanent power down to the switch, and then we need to figure out how to get a switch leg back up to the light to actually turn the light on and off. And we could actually do that fairly easily with 3-conductor. Remember, 3-conductor actually has 4 wires in it. Now there is a way we could do this with a 2-conductor plus a ground cable. That's going to be called a switch loop. That's going to be something we'll cover in a different video. The code book generally requires us to have a neutral available at any switching location, so we have to bring this neutral down to the box. We're just going to have a single pole switch down here, and there's no need to have a neutral here, but we have to have that neutral available just in case somebody wants to install an occupancy sensor, a smart switch, some type of switch that does require a neutral. So in order to fulfill that requirement, we need to bring a 3-conductor plus a ground from our light box down to our switch box. And then we can do all of our switching down here and send that switch leg back up, probably on the red wire. So with our 3-conductor cable ran, we can go ahead and start making up our light box. We already know that we don't need a ground up here at this box for those keyless lamp holders. But because we do have ground wires available here, we have to tie them together to pass that ground through the box. So I'm going to start this box by connecting the 2 ground wires together. That way we can coil them up in the back of the box and they're going to be out of the way. Next, let's take care of the neutrals. Now we do need a neutral here at this box, right? So we've got neutral coming in from the panel and neutral going out to the switch. Now remember, we don't need to use this neutral at the switch, but we have to have it there for code compliance. But we also need that neutral here at this light. So that means we have to pigtail out another neutral to be connected in this box. And with the neutral pigtailed, that can also be tucked back in the box. We want to leave that pigtail poking out so we can tie it onto that keyless lamp holder. All right, now we've got a couple more wires left over here. Now what do we do with these? This right here is permanent power coming from the panel, and this wire right here is going to be permanent power going down to the switch. Do we need permanent power up here in the light? We don't. So all we need to do is actually just tie these 2 black wires together to send that power straight down into our switch, and then it's going to come back switched on this red wire. And that's it. No pigtails on this because we don't actually need to use permanent power in this box. If we wanted this light to be on all the time, then we could absolutely pigtail off of this permanent power, and that's where we could get power from. That would kind of negate the purpose of having this switch leg up here, but it could be done. Maybe this is a night light and maybe this would go off and feed other lights. That would be a possibility. And now all that's left up here is our switch leg, which we can simply trim and put a loop on. And now we're left with the 2 wires that are going to land right on the keyless base. Remember, neutral goes to the silver screw. And our switch leg is going to go on the gold colored screw. It is important to keep track of the colors on these lamp holders. The light bulb doesn't care, but if you were to go up here and grab the light bulb and you were to come into contact with that outer shell from the light base, if you touch that, that's supposed to be neutral, and that would minimize your chance of getting shocked. But if you flipped these 2 wires around and you heated up the outer shell of the actual light, you could get electrocuted when you go to change that light bulb. So it is a safety issue keeping track of those colors. And that's all that needs to be done in the light box, so it can be closed. And now down in the switch box, we simply land the wires on our switch. All of the wires will land on the switch except for the neutral. We are not going to use the neutral in this box, but we do have to keep it insulated. And because it is cut off bare copper at the end of this wire, we do need to put a wire nut on it. So I'm just gonna strip this back just a little bit, and we're gonna put a wire nut on it. Do you have to strip this before putting a wire nut on that to cap it? Technically no, but there is a chance that when you put the wire nut on just raw insulation, the wire nut can actually cut the insulation off and the insulation can pop off with your wire nut, leaving a bare connection. So I have found it's best practice just to go ahead and strip it out to begin with, and then you can put your wire nut on there. Now this wire can be tucked into the back of the box because we will not be using it in this scenario. I also want to make note, because I bought these cheaper boxes that don't have those little fingers in it, this knockout is knocked out. If this was a real installation, you'd want to cover that up with some sort of tape to cover that hole. Rodents absolutely would crawl into that and then chew all your wires up in here. That's going to be something you're going to want to avoid. In this case, I'm actually going to use that hole in the next scenario. So for now, I'm going to leave it. But again, in the real world, you'd want to cover that up somehow so rodents cannot get in there. And believe me, they will absolutely get in there. I can barely fit my finger in there, but you bet a mouse would figure out how to get in there. And as we've seen multiple times now, green screw is our ground wire. And again, it does not matter which side of the switch the hot and the switch leg go on. I'm just gonna choose the bottom here as our hot, and then that would make our switch leg this top terminal. If you're on a bigger job where you're doing a whole bunch of switches, you will want to be consistent on putting your hots on the top or the bottom or however you choose. Just be consistent with it. That way when it comes time to troubleshoot something, whoever has to go in behind you and fix that is going to be able to know, okay, the last 6 units, the hot has been on the top. That way they can start to assume that the hot is going to be on the top for the rest, and it will make troubleshooting easier. With that, the switch is ready to be buttoned up. Contact, and we flip the switch. Even though we're feeding power into the light, we're still able to switch it. All we have to do is extend that power down to the switch, and then we have to bring back a switch leg. Neato burrito. For our final scenario, let's swap this out for a 2-gang box for 2 switches and have one switch control this light, but let's add a switched receptacle from this location as well. Let's use that split receptacle. We'll use that receptacle over here. The top of the duplex will be hot all the time, and the bottom will be switched from that second switch over here. All while still having the home run feeding the light box up top. Shut power off. So all I've done is swapped this box out for a 2-gang, and I added a single gang box over there and added a 3-conductor cable between them. Now things can get a little confusing when we see boxes like this. We have color for color, but they are not going to get connected color for color. We have to ask ourselves, what do we have and what do we need, right? So what do we have here? Well, coming from the top, we've got ground, we've got neutral, and we've got permanent hot. That's what this black wire is coming from our light box. And this red wire is what actually connects to the light up top. So this is the switch leg going up to the light. Down here is a little bit of a different story. This black wire is going to be our permanent power that's going to go out and feed the top of the duplex receptacle. Of course, we have ground that needs to go over there and ground the receptacle, neutral to actually feed the receptacle as well. And then we've got another red wire. Now this red wire is also a switch leg, but it is a separate switch leg that is going to feed the switched portion of that duplex receptacle. So there are some things that we can tie together here. Let's start with the grounds. So what do we have? What do we need? Well, we have ground here, but we've only got 2 wires, and these need to feed through. But we need 2 more grounds in order to ground the switches that are going to be installed in this box. So we need to pigtail on 2 ground wires in order to ground these switches. I'll just reuse these 2 pigtails right here from our previous demonstrations. Line all 4 of the wires up end for end, and we can spin our wire nut on. Always, always, always check with the tug test. That passes. And now we can tuck this ground into the back of the box. Next up, let's take care of the neutrals. We have neutrals here and they need to pass through. Now we have to ask ourselves, do we need to use those neutrals in this box? We are only using single pole switches here. No, we do not. Now, that does still satisfy having a neutral available at this box. If we were to change these switches out in the future to some sort of electronic switch that did need a neutral on it, we'd be able to pigtail this neutral and get that neutral to the switches if we ever needed to. So we are just gonna pass these neutrals straight through the box. Our neutral is gonna come in from up top and it's gonna go straight out and over to the receptacle. No need to pigtail right now. Now, if we knew for sure that in 3 weeks, the customer is going to be installing occupancy sensors here that are gonna need a neutral, we would absolutely pre-pigtail this out and have the wire nuts capped there. That way, when it comes time to installing the new switches, it's a lot quicker. In this case though, we're just gonna pass this neutral straight through the box. Same thing here, we'll tuck that neutral in the back of the box. And now we've still got a mess of wires, and again, they're the same colors, so it gets a little confusing. How do we tie these in? We have to ask ourselves, what are the purpose of these wires? We can't just go by color alone. So if we separate them, we can see that we've got the 2 wires going up, a black and a red, and then we've got the 2 wires going down out to our switch, a black and a red. The black wire is where power comes from. This is our permanent power coming from our light up above. We need to continue that permanent power on to feed the permanent power portion of that receptacle. So these 2 are going to need to get tied together. But again, we have to ask ourselves, what do we need at this box? Well, we also need 2 permanent powers to feed our switches here. So we need to pigtail on an additional 2 black wires to feed permanent power to these switches. So power in is getting tied to power out, and then we are pigtailing on 2 additional short pieces to feed those switches. Make sure all these wires are end to end, and the wire nut will take care of the rest. You absolutely can pre-twist, and it does make this step easier, but so long as the wires pass the tug check, you know it's a good connection. And then our permanent power can get tucked in the back of the box. And now we've got a ground and a permanent power for the right switch, and we've got a ground and a power for the left switch. And all that's left that's undesignated are these 2 switch legs. So let's have the switch closest to the receptacle actually switch that receptacle. So we'll put the red wire going that direction over here. And then this wire that's actually going up to the light, we're gonna leave over here on the left. So these 3 wires are gonna go on the right switch, and these 3 wires are gonna go on the left switch. Green screw is the ground, and then the gold screws do not matter top or bottom, whether they are permanent power or the switched power. Just make sure that wire is looped around clockwise. That way the wire does not unwind as you tighten it. This switch is landed. Let's land the second switch. And just like that, both switches are landed, so we can push these into the box. So our switch box is done. Let's head over and do the receptacle box. I am gonna reuse the receptacle we made for the previous installation where we've already broken off that bridge right there. The bridge for the neutral side is still intact. So really all there is to do over here is land all 4 of these wires on the receptacle, just like we did in the previous installation where we used this receptacle as well. Ground the green screw, white to one of the silver screws. Again, it doesn't matter which silver screw because we still have that jumper on the receptacle. But on this side, if we want permanent power on the top, our black wire has to land on the top. For switched power to be on the bottom, we need our red wire to the bottom terminal. Another caution is if you were to do this out in the field and you forgot to remove that jumper wire there, your receptacle is not going to act correctly with your switch. You're going to flip the switch on and off, and your switched receptacle is always going to be on because it is permanently jumpered there. So keep an eye out for that if you run into some issues with your switched receptacles not working. Maybe you forgot to remove that jumper on the hot side, or maybe one of your receptacles doesn't work. Maybe you accidentally removed one of the neutral jumpers, and that would actually prevent that bottom receptacle in this case from actually working. So those little jumpers, when you start removing them, they can start to become a nuisance. So be very careful of that. And now this receptacle can be installed. And we'll install our receptacle testers in our receptacles and fire up our circuit. Notice, as soon as I turned that on, the top receptacle came on, even though the switches are off. If we flip this second switch, notice that bottom receptacle is now switched, just like it was before. And of course, our left light switch still controls the switch above it. Now remember, we're still feeding power into this light. So all of this stuff down here, power is still originating in this box right here, even though this is something that we are switching. The most complicated part about an installation like this is just understanding that your cables can be used bidirectionally. We are sending power down on this 3-conductor cable, but we are sending that switch leg back up. We are actually using this 3-conductor cable for 2 different purposes. We are sending permanent power out to this receptacle, but we are also sending out that switched power for that bottom receptacle. So cables can actually work 2 directions. Yes, the individual wires in those cables can only really do one thing at a time, but if we have multiple conductors in the cable, we can actually start sending these signals in different directions. Single pole switches can be used for a multitude of different jobs because they are so universal. All they do is interrupt a circuit, and they can actually feed any kind of load. It can be a light, it could be a receptacle, it could be a fan, it could be a pump, it could be a motor, it could be any one of those things. Once we understand the core principles of how switching works, we're able to start piecing together fairly complicated circuits that may not necessarily be all within the same 10 square feet here, but they could be across a building, and we're still able to do those switching concepts over those larger distances. If you made it this far, consider liking, commenting, and subscribing if I've earned it. Thanks for watching. We'll see you on the next one. Bye.